Good evening everyone. Let me share my PPT just a moment. Okay, so in the yesterday's video, I think just a moment, let me just move this one backwards. Yeah, in yesterday's video, so we started with what do you mean by center of mass and how do people make a mistake in this. The mistake which generally it has been found when we talk about center of mass is that usually consider geometric center to be equal to center of mass, which is incorrect. That's what we saw about here. And wherein we took about three discrete particles of masses M1, M2, M3, and they were all arranged at the vertices of an equilateral triangle. And usually they consider the center of mass is nothing but it's been found in the centroid, which is incorrect. Okay, and thus we found out what is the center of mass. This was the center of mass. Okay, so I have shown you all the calculations how to do it. So if you have not gone through my video, please go to the previous video so to get a clarity of what do you mean by center of mass, what formula do we use and so on. If you want, I can just say that this is my center of mass formula. Okay. Now let us look at one more example. So here also I have seen many students make a mistake. Now what is the mistake? Now it says, the problem says a uniform disk of radius r is put over another uniform disk of radius 2r. So you have a big disk. This is a big disk of radius 2r. Of radius 2r. Let me write it down. This is my 2r. And what does it say? Of same thickness and density, the peripheries of two disks touch each other. Peripheries of the two disks touch each other. It means what? A uniform radius or disk of radius r. You have one more disk in such a way that this touches this point here. I hope you are able to visualize this. So what it means is that, so here you have radius r and here it's 2r. Okay. So if this is 2r, then when I say uniform disk of radius r, it means the diameter of this should be equal to 2r. That's what we have. Okay. And now, just give me a moment. Okay. Back. So therefore, so I said that this radius r, this radius 2r, okay, of the second disk. This was the second disk. Let me write this as second disk. This is the first disk. This is the first disk. This is the second disk. This is the first disk. Okay. Now look at the center of mass of system. So usually what students do is they consider anyway the mass of this one would be at this point. So I will approximate the whole mass to be at the center. So this is center. And this mass would be at this point. At this point. Where is it? It will be at this point. Okay. Now what is the distance between these two? Distance between these two would be equal to r. So this is 2r. So this would be equal to r, radius r. And thus distance between these two would be, center of mass would be midway between r and 2r. Between r and 2r, which means here, between this point, let me call point O, and this may call as point A, it will be midway between them, point B. Okay, point B was the center of mass. And what could be the distance? Distance, as usual, as you know, distance OB will be equal to r by 2. Okay, this is the answer most of the students give me. Now let us see how does it differ. Okay, this is a completely incorrect way of writing it. Let us see what happens. Now the first misconception is, okay, so first thing that you actually did correctly was that you located the center correctly. Okay, the center of the bigger disk is at this point. Let me call this as point O. The center of the smaller disk is at the point A. The distance between these two is nothing but r. Did you find out what is the mass of this point O? Point O is a point O only, right? Okay, how do we get a mass? So we have assumed that the center of mass of this object lies here. Now, what is the center of mass of the object? Let us see that. So towards it, now what is the radius is 2r. The mass can be written as, what does it say? Same thickness, same density. Okay. So mass can be written as volume multiplied by density, right? Where rho is the density here. So thus I can now write volume. What is volume? Volume for the bigger disk. Volume for the bigger disk would be pi r square. Pi into r square. What is r square? R is nothing but radius. So this should be 2r. 2r the whole square multiplied by the thickness. It says same thickness. Okay. Thickness. What is thickness? Let us say thickness is some t. Thickness is some t. Okay. So this is my thickness. This is my thickness over here. This is my thickness. So this is t multiplied by density. Same density. So I have this one. Let me call this as M2. M2 I got this. So let me write down the whole thing, which will be pi into 4r square t into density. Now let us take the smaller disk. Smaller disk has a mass m1, which should now be equal to pi into r square into t into rho, right? Now what do we need here? Now we have got masses over here. Now we need to find out what is the center of mass. What's the formula for center of mass? Formula for center of mass is xcm should now be equal to m1 x1 plus m2 x2 divided by m1 plus m2. Similarly, we can have YCM also, but unfortunately, we are looking only that the radii is coinciding here. That's what this term means. Two peripheries of the two disks touch here, which means what? The center of mass of this big disk and the center of mass of the smaller disk both are in the same line. So therefore, you need not look at y-axis, right? You can only look at x-axis because it does not stay here, right? Why it doesn't stay? Because this will not have any y-coordinate. This will also have not any y-coordinate. Or whatever y-coordinate you have here, the same y-coordinate here. What's the y-coordinate for this one? 0, right? What's the y-coordinate? 0 only. Because they are on the same straight line, correct? Okay. Now what we will do is, let us choose that this is my origin. The point O is my origin. And this is at a distance r. So what are the coordinates? Let us write down. The coordinates here are 0, 0, since it is origin. And this point is at a distance r from the origin. So this will be x, y, which will be r, 0. So this will be 0, 0, and this will be r, 0. This will be r, 0, right? Now what do we need to do? We need to plug in the values. Now what is x1, y1 and x2, y2? See, this will be your x1, y1, and this would be your x2, y2. Correct? Now let us substitute this value. This should be equal to m1. What is m1? m1. Where is m1? It's here. Okay. So I will write this as pi r square t into rho into x1. What is x1? 0. Why do I write it? Okay. Plus m2. What is m2? 4 pi r square t into rho. And what is x2? x2. Where is x2? x2 is here. r2. r2, which is r here. Okay. Divided by m1 plus m2. What is m1 plus m2? Pi into 4 r square t rho plus pi into r square t rho, which should be pi r square t into rho. So what will happen now? T rho goes away. R square goes away. Pi goes away. So what am I left out? I left out only with 4 here. And then you have an r here divided by 5 here. That's what is the answer here. So xcm is equal to 4r by 5. If you still say, okay, sir, how is that the YCM becomes 0? You're not done it for YCM. If you want, I can do it for you also. Okay, so let us do for YCM similarly. Okay, YCM. I don't have space here. What will I do? Okay, I have some space. Take my photo. Okay, now let me do it here. So for YCM, this is for YCM. Okay, what is the center of mass coordinate for along the y-axis? Along the y-axis, what is the formula? m1. I'm just going to replace x by y1. Okay, so this should now be m1 y1 plus m2 y2 divided by m1 plus m2. So this should now be equal to, what is m1? m1 I can substitute. I'm not going to substitute anything here. I'll just write m1 into what is y1. See, y coordinate is 0. So it is 0 plus what is m2? m2 I'll just write m2 itself. And what is y2? y2 once again is 0. 0 divided by m1 plus m2. So numerator is 0. So therefore YCM is equal to 0, right? Okay, logically also you can go, or mathematically also we should get the same answer. Okay, I think we have solved this. Thus the answer now should be 4r by 5, which means where should the center of mass lie? 4r by 5 will be 0.8 times r, which means what? It is in the disk, in the second disk. In the first disk, it is only 0.8 times that of the r over here. It is not at r by 2 as we had predicted. Remember, center of mass need not be the geometric center of all the objects. It can be, it may not be. Okay, in this case, it is not. Okay, I have put two disks, and then we have found out the center of mass of the full system. As a result of it, it is not equal to r by 2. I hope you understood this concept clearly. If you still have some questions, do drop into my chat box, because I know there's a new concept altogether. So I would be happy to answer them. Thank you, friends, for watching this. It's my next one. Yeah. Okay. So what you can do is, if you have any more questions, you can put it across. Thank you, friends, for watching this. So like, share, and subscribe to my channel for more updates.